Okay, so what we're going to do is look at another equation of a parabola. So we're going to go back to, basically the starting point here. Here's an equation that's not even in the right form for us to find the information. So we're going to have to complete the square to get the equation of the parabola. And then once we get that, let's find all the information that we can. So remember that with writing the equation of a parabola, so noticing that I have a y squared, I know I want my equation to look something like this. So basically what I need is the perfect square on one side and everything else on the other side. So y is on one side, x is on the other. We could look at it that way too. So what I'm first going to do is I'm going to leave the y squared and the 10y on the left, and I'm going to write negative 8x minus 1 on the right. So then what I have to do is figure out, well, what do I need to add to both sides to make this a perfect square on the left? And I notice that half of 10 is 5, and 5 squared is 25. So I'm going to add 25 to both sides. And I know that that guarantees me a perfect square. So I'm going to rewrite the left-hand side as a perfect square. So that's y minus 5, the quantity squared. And on the right, I have negative 8x plus 24, which I'm now further going to write as, factoring out the negative 8 times x minus 3. Because remember, in the standard form, or whatever form you want to call this, we need to have the entire coefficient outside and just an x on the inside of the parentheses. So it looks like we're set. What I can tell right now is that our vertex is 3, 5, because it's x minus 3 and y minus 5. And I can also tell that 4p is equal to negative 8, which means p is equal to negative 2. So that tells you that I'm opening in some kind of negative direction. And since it's a y-squared parabola, I know it opens horizontally, left or right. And since p is negative 2, I automatically know that it opens to the left. So if I plot the point 3, 5, just to get some sense of what's happening here, remembering that p is negative 2, which means that my focus must be on the left of the vertex. In fact, if it's 2 units to the left, so here's my opening, and I know my focus must be on the left there, so I'm going to subtract 2 from the x-coordinate. That gives me the point 1, 5. So I know that that's where my focus is. Great, we got our focus. So now the other part of the problem is, how can I get some more points on the parabola so I know exactly which way it opens? Because a vertex and a focus doesn't really tell me all that much. Well, remember that if the focus is p units from the vertex, if the focus is p units from the vertex, the other 2 points on the parabola, symmetric points on the parabola, are 2p units from the focus. So that means that my other points are going to be, let's see, p was negative 2, which means 2 units away. So that means I'm going to have one point that is 4 units above the focus. I'm just going to erase this to make this a little more clear. So I know I have this point, and I know I'm going to be 4 units below the focus. So I basically know that my parabola has this shape right here. And as far as what points are those, well, we do already know that this point right here is 1, 5. So this must be the point 1, well, let's see. If this is 4 units, that means this must be 9. And if this is 4 units, this must be 1, 1. Now, if we go to any form of the equation of the parabola, I'm just going to pick the original because that's where everything started. Y squared minus 10y plus 8x plus 1 equals 0. So if I substitute 1, 9, well, let's see what we get here. I get 9 squared minus 10 times 9 plus 8 times 1 plus 1 equals 0. So that's 81 minus 90 is negative 9 plus 8 plus 1 equals 0. That's going to work. So that's great. Okay, and if I plug in the point 1, 1, well, that means 1's everywhere. You get a 1 and you get a 1. So 1 squared minus 10 times 1 plus 8 times 1 plus 1 equals 0. So let's see, this is 1, and 8 is 9, and 1 is 10. And so that's 10 minus 10 equals 0, and that works too. So those are definitely points on the parabola. Okay, another way you could look at it is this. If you take the squared equation, remember the whole idea is we have a point that shares something in common with the vertex. It has the same y-coordinate as the vertex. So what we want to know is what points have a point in common with the focus. We want to know which ones have the same x-coordinate. So knowing that x is 1, I could also take y minus 5 quantity squared equals negative, what was it, negative 8, x minus 3. I want x to be 1 because that shares something in common with the focus. And I know that that's 16. So I want y minus 5 squared to be 16, which means if I take the square root of both sides, I want y minus 5 to be plus or minus 4, just taking the square root of both sides. And then that gives me y equals 5 plus or minus 4. Well, and 5 plus 4 is 9, and 5 minus 4 is 1. And hey, that worked out, didn't it? So we have, we have 1 comma 9 and 1 comma 1. So lots of ways to get those, but the easiest way, obviously, is to use the 2-unit rule to get the other points on the parabola. So hopefully that's helpful, and I thank you for watching.